In order to ask myself whether compartmentalization was inevitable and whether it was a problem in other subjects, I went back to the teacher who taught me quantum mechanics and special relativity in Cambridge in the 1960s, which Ernst mentioned was my early subject. And Bill Saslaw gave me three very powerful examples. He gave the greatest physicist of the last century and the greatest chemist. Albert Einstein was interested in unifying his subject through trying to understand and propose a grammar. He called it, his own words, a grammar of physics, which stretched across the subject. And he wrote, of course, on issues from the cosmic to the ultra-micro and inside the atom. Linus Pauling, the greatest chemist of the last century, brought quantum mechanics to chemistry. He charted the inquiry into DNA, which Crick and Watson eventually took forward. He pointed to the chemical nature of mental, or the possibility of the chemical nature, biochemical nature of mental illness. He identified the genetic element in a number of diseases, and he wrote, of course, on vitamins, and I could continue. Here again was somebody who did well. He didn't simply straddle his subject. Part of his creativity was in the straddling of the subject. A different way, he was applying quantum mechanics to chemistry, but in a similar spirit to Einstein. Richard Feynman unified quantum theory, special relativity, and the theory of radiation, and his unifying approach was by using simple methods for complex calculations, which he could then apply to different parts of his subject. But of course, he had to know the different parts of his subject in order to apply them. Now, Richard Feynman was also a tremendous safe breaker, lock picker, juggler, and bongo player. He had a number of dimensions to his personality, some of them rather unpleasant, it seems, in his activities in various bars around the world. But that's not part of my story of richness and breadth. I was speaking about the academic side. So in physics, we find that great discoveries can come from openness and breadth, combined always, of course, with intense analytical power, in the case of all those examples that I have given. In economics, I think the story is a little bit different. I do think that great discoveries can come from that openness and breadth, but I think it's a slightly different story. I think in economics, unless we have that kind of perspective and coverage, we risk grave error and damage. So it's a different kind of payoff to breadth, but I think it's just as important. Now, compartmentalization is difficult to measure, it's difficult to assess its consequences, it's difficult to know how to respond to it, but I think at least we should be asking ourselves that question. Now, let me just spend a few minutes on illustrating some of these ideas through climate change. I suppose you'd expect that of me. And I do think it does illustrate a number of these things. It illustrates the dangers of ignoring public economics. It illustrates the dangers of applying public economics in a narrow way. And it also reminds us that we're in danger if we insist on applying marginal methods only to a severely non-marginal problem. But it also leads in, and this is to the last part of what I have to say, into, and indeed there's some formal and conceptual links with the intertemporal issues which arise in climate change and some of the intertemporal issues that arise in behavioral economics. So I want to draw attention to those formal links as a bridge, as it were, between this part and the last part of what I have to say, which is about some of the stories of behavioral economics and theories of justice. But let me just remind you of the non-marginality. We are at around 435 parts per million of CO2. We're adding about 2.5 parts per million a year. That 2.5 parts per million a year, which we're adding to the concentrations of greenhouse gases, is rising. If we do not much over a century, we will add an average of 3 or 4 a year, well, 3 or 4 times 100, added to the 435 where we are now, and we would be at least 750 or so by the end of the century if we did not very much. If we let that happen and stopped accumulating emissions in the atmosphere right there, The standard theories and models, for example, of the Hadley Centre in the UK, would suggest that there's a 50-50 chance the early part of next century of being 5 degrees centigrade above the middle of the 19th century, which is the usual benchmark. Now, 5 degrees centigrade in February in Moscow doesn't sound like a problem, but this is a huge transformation were that to happen. We have not been at 5 degrees centigrade above the middle of the 19th century for around 30 million years, the Eocene period. Human beings have been around for 100 or 200,000 years. They've not seen anything like that. We have seen 5 degrees centigrade below, and that was very recently, 10 or 12,000 years ago, in the last ice age. That kind of change transforms where people can live. 5 degrees centigrade upwards would transform where people would live. Where we are now would look like probably the Sahara Desert. Other parts of the world would be probably submerged. The risks that we run are just enormous, and the kinds of income standards or living standards that would be associated with them would be radically below where we are now. It would lead to hundreds of millions of people moving, probably billions, and extended and global conflict if we draw the lessons of the last few hundred years about what happens when large numbers of people move. Now, that is a description of what the science tells us. It's basically 19th century science. It just applies the laws of physics and chemistry. Arrhenius won his Nobel Prize in this at the end of the 19th century for quantifying some of these effects. This isn't new stuff. It's as basic, really, as the laws of thermodynamics or gravity. I'm not going into all the detail, but I did want to underline, because it's fundamental to the whole story, that this is non-marginal change. We cannot apply a naive Pigovian story of taxes to externalities. It is an important insight. It is a relevant insight. It's one of the places to start, but it cannot be, given this kind of scale of effect, where we should finish in our analysis of policy. There are other kinds of market imperfections too, associated with developing new technologies, associated with the markets for buildings and the recouping of investments in energy efficiency in buildings. There are all kinds of externalities of the specific kind which occur, and market failures which occur elsewhere. So we cannot deal with climate change unless we deal also with those issues. So again, public economics is an important step forward, but in this case, not even the simple-minded view of public economics, which could have been so valuable over the last 20 years, is enough. We have to develop and look at theories of non-marginal change, think about strategies for growth or strategies to prevent collapse in this kind of framework. It's a different kind of modeling, but it's based on the stories of what could happen and based on the evidence. Let me just give one other example of why we have to be creative and thoughtful and use what we know in a broad sense when we come to climate change. And that is the idea that somehow you can read off the relevant intertemporal values or rates for discounting from markets. It's a profound mistake in this area. Actually, at least 5 mistakes involved in doing that, and some people have managed to make all 5.